the project design entitled Development and Evaluation of a Solar-Powered Detecting, Alarming, and Notifying Security System. Security cameras are a great way to provide our security, even if we are at home or workplace, in daylight or nighttime. By the use of cameras in a certain place, it provides us a sense of security and also a video footage of any events which may happen. They also act as a visible deterrent to criminals. General objective. The general objective of the project is to develop a solar-powered base security system. Specific objectives are: first is to design and build a system that incorporates a solar power source, outdoor camera, alarm system, and wireless connectivity from a post to a base station, and send message to a Dropbox if internet is available. The second one is to test and evaluate the technical specification of the device using the following parameters. Number 1, angle of coverage of the camera. Number 2, the minimum and maximum range of the alarm sensor. Number 3, the minimum required solar panel, solar controller, and battery for a 24 hours operation. Third is to evaluate the perceptions of the two groups of respondent based on the following criteria: functionality, aesthetics, workability, durability, safety, and maintenance. And last, to test if there is no significant difference on the evaluation of the perceptions of the two group of respondents based on the given criteria.
Conceptual framework. Figure 1 shows the IPO model of development and evaluation of solar power detecting, alarming, and notifying security system. The input contains our reference and materials. The reference needed are books and internet. Materials: laptop, act as a base station. It received the dataset by the CCTV. Raspberry Pi 2. It is a capable little device that enables of people of all age to explore computing and to learn how to program language like Scratch and Python. Microcontroller, a computer present in a single integrated which is dedicated to perform one task and execute one specific application. CCTV camera, the most important part. It monitors the area and sends information to the base station. Antenna. Yagi-Uda antenna contains a single driven element connected to transmitter or receiver with transmission line and additional parasitic element. Solar panel. Used as the main power source. It absorbs solar energy. Battery. Acts as a backup source when the weather is cloudy or rainy. Router or access point. Provide connection between CCTV and smartphone. Tablet or smartphone. Can also be used as a base station. Motion sensor and wireless buzzer. Used for the security of the unit itself. It alarms the base station when the movement is near at the unit is sent. Process. First and foremost is the design and construction of solar power detecting, alarming, and notifying security system. The SPDANs is to be set up in the higher post to be able to monitor a wide area, but we will use shorter posts to be presented in the defense. Configuring the Raspberry Pi 2 and establishing connection of the router and base station. The smartphone should be able to connect the router installed in the SPDANs. Testing, evaluation, and revision. The smartphone should be able to receive the image captured by the CCTV using Dropbox. Evaluate and revise any error till it perform is acceptable. Output. Develop and evaluate solar power detecting, alarming, and notifying security system, which can be controlled by laptop or computer, tablet or smartphone. Reject or accept significance difference in the evaluation.
Presentation, analysis, and evaluation of data. After the following careful design and procedures, the block shown is the interrelationship of the output project. Block diagram of the development and evaluation of the solar power detecting, alarming, and notifying security system. Two 20-watt solar panels are connected to the solar power controller. It provides solar energy, which is the main source of the development and evaluation of the solar power, detecting, alarming, and notifying security system. The battery is also connected to the solar power controller. When the solar panel fails to gather solar energy, the backup battery is used instead. It can be the power source for 3 to 5 days and it is rechargeable. The camera in the Raspberry Pi 2 monitors the area. The data that is gathered will then be passed to the access point, where it can be accessed by smartphones and the antenna, where the information will be sent wirelessly to the base station. When the motion sensor senses a movement, the wireless buzzer will alarm that is placed in the base station.
The weighted mean for the acceptability of the development of the solar power detecting, alarming, and notifying security system as perceived by the respondents is presented in Table 4.3. Based on the perception of its functionality, it got an average weighted mean of 4.06 from the community and 4.17 from experts. Aesthetics with an average weighted mean of 4.5 and 4.42. Workability has an average weighted mean of 4.17 and 4.06, while the durability has an average 4.17 and 4.44. Finally, safety and maintenance has an average weighted mean of 4.46 and 4.04, all with a verbal interpretation of very acceptable. Table 4.4 and 4.5 depicts the data if there is no significant difference on the evaluation of the two groups of respondents based on the given criteria. Before computing for the t-test, we first use f-test in table 4.4 to find if there is a difference in the variance of the two variables. Since the variances are equal, we compute for the t-test assuming equal variances. It is shown that there is no significant difference in the evaluation of the two groups of respondents based on the given criteria for the development of the solar power detecting, alarming, and notifying security system. It is implied that the development for the solar power detecting, alarming, and notifying security system is very acceptable.
A security system device entitled Solar Power Detecting, Alarming, and Notifying Security System was developed with the integration of the following devices, namely solar panel, solar power controller, surveillance camera, motion sensor, wireless buzzer, and router. The angle of coverage of the camera is 180 degrees with the help of the lenses. When fully charged, the maximum range of the alarm sensor is up to 99 feet. The required specs are 40 watts solar panel, 10 ampere solar controller, and a minimum 10 ampere per hour battery. The development of the SPDATs is very acceptable as a result of the evaluation of the two groups of respondents based on functionality, aesthetics, workability, durability, safety, and maintenance. As to the level of acceptability of the solar power detecting, alarming, and notifying security system, the hypothesis that there is no significant difference in the level of acceptability of the two groups of respondents with respect to its functionality, aesthetics, workability, durability, safety, and maintenance was affirmed very acceptable.
Recommendations. Based on the foregoing findings of the study, the following are recommended for future enhancement of the developed solar power detecting, alarming, and notifying security system. First, higher battery capacity. Second, develop to be water resistant. Third, reduce the delay of the sent images. Fourth, improve to able to alarm multiple buzzers from different places. And last, improve maximum range for communication.